Bright Tuty. Every student matters.
Now let's do this exercise. This question is pretty simple for you. We need to find the area of a circle with radius 6 centimeter if angle of the sector is 60 degrees. Now this angle is 60 degrees, right? And we need to find area of sector. Okay, radius is 6. This is center. So area of this sector will be equal to angle theta by 360 pi r square. So angle theta is equal to 60 degrees by 360 pi r square, which is 6 square, right? So this is the area of this sector. You can cancel it, 6. So this 6 is gone here. So 6 pi is the area in centimeter square. 6 pi centimeter square is the area of this sector. Okay. If you take pi as 3.14, you can give the approximate value in decimal form also. .84 centimeter square, right? I'll leave this calculation to you. Okay, I'm just giving you an idea how to do this question, and I expect you to do these calculations yourself. Okay. Find the area of a quadrant of a circle whose circumference is given as 22 centimeter. Quadrant is the fourth part of the circle, right? If this is the circle, and if I divide it into 4 equal parts, okay, so this is one quadrant, this is one quadrant, this is another quadrant, this is another quadrant. So this angle is 90 degrees, okay. Full angle is 360, so I have divided into 4 equal parts, which are quadrants, okay. So this is 90. So what is the area of a quadrant? It is 90 by 360 pi r square. So it is 90 by 360 pi r square, hence it is fourth part, 1 by 4 pi r square. Okay, so you can directly write area of quadrant of a circle is 1 by 4 pi r square. Now you need r, but you are given circumference. So 2 pi r is given if r is the radius of the circle. 2 pi r is equal to 22. Now if I write this pi as 22 by 7, so it is equal to 22, 22 gets cancelled, r is equal to 7 by 2 centimeter, right? So area, required area, or you can say required area of this quadrant is equal to 1 by 4 pi r square, which is 7 by 2 square. So if you replace this pi by 22 by 7, you can write it like 7 by 2 into 7 by 2 and do the calculations yourself. Unit will be centimeter square, right? If you want to convert it into decimal form, you can divide it and convert it yourself. Okay. The length of a minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. Okay. Let us say this is the clock that we are talking about, and this is the minute's hand, right? This is 14 centimeter. So if this minute's hand sweeps the area, right, like this, let us say this moves here. So this will be the area swept by this minute's hand. Now this minute's hand is moving, so it is acting like the radius of the circle, right? The minute's hand is moving like this, so it is creating a circle, right? So I need to calculate area swept by this minute's hand in 5 minutes. Okay, so what I need is this angle, because the area will be theta by 360 pi r square. R we already know is 14 centimeter. Theta we don't know, so we need to know the angle made by angle swept by the minute's hand in 5 minutes, or angle made by the arc swept in 5 minutes. Let us say this minute's hand moves from this position to this position in 5 minutes. So this angle we are talking about, right? So we are concerned about this angle. So how will we calculate this? In 60 minutes, angle swept is equal to 360 degrees, right? So in 1 minute, it is 360 by 60. We have done this in introduction, so you should be very clear about it, 6 degrees. So we need angle swept in 5 minutes. So in 5 minutes, it will be 6 degrees into 5, which is 30 degrees, right? So now we know the angle made at the center, okay? So area swept in 5 minutes is equal to angle 30 degrees by 360 pi r is 14 square. This is 12. So pi into 14 by 12, right? You can simplify it yourself. 6, 7, 3, 7. So it is equal to 49 pi by 3, right? This is pretty simple calculation also. 49 you can write it as 22 by 7. So 3 here, 7 will get cancelled here, right? So it is equal to 154 by 3 and the unit is centimeter square. Okay. So this is the area swept in 5 minutes. Alright, so let's move to the next question here. A chord of a circle of radius 10 centimeters subtends a right angle at the center. So the question here is, there is a circle and there is this chord which subtends an angle of 90 degrees at the center. So this angle here is 90 degrees, right? And the radius is 10 centimeter. So this is 10 centimeter, this is 10 centimeter. This is the center of the circle. We need to find the area of minor segment. So we are talking about this area here, right? To calculate this area, let us name these points A, B, and let us name this as P, okay? So area, first subpart, area of segment APB is equal to area of sector OAPB minus area of triangle OAB, right? What is area of sector OAPB? This is 90 degrees, so this is just a quadrant of the circle. So it is 1/4 of area of circle, or as we usually do, theta by 360 pi r square, which is 10 squared. So this is the area of this sector OAPB minus area of this triangle OAB, which is a right angle triangle. So half into 10 into 10, right? You know how to calculate the area of a right angle triangle. So this is the area of segment APB, which is, this is 4. So you can write it like, this is 100 by 4, so 25 pi minus, this is 100 by 2, 50, okay. You can further simplify it yourself by taking pi equal to 22 by 7 or 3.14 as mentioned in the question, okay. So right now let me take it as 3.14, 25 into 3.14 minus 50. So we can take 25 common, 3.14 minus 2, so it is equal to 25 into 1.14, okay. So what we can do here is, we can write this 25 as 100 by 4 into 1.14, so this is 114 by 4, so which can be further simplified as 328.5 centimeter square, right? So this is how you can calculate the area of segment APB. And this calculation part I expect you to do yourself. So I will be giving you hints in the questions coming further. So I need to calculate now the area of major sector. I know the area of this minor sector OAPB already, which is equal to this, right? So I can calculate the area of major sector by subtracting it from the area of circle. So second subpart, area of major sector is equal to area of circle minus area of minor sector. Or another way to look at it is minor sector is 1/4 of the circle. So the major sector is 3/4 of the circle. So it will be essentially 3/4 of pi r square, right? If this is pi r square, this is 1/4 pi r square. If you subtract it, you will be left with 3/4 of pi r square. So what is r? R is 10. So your answer will be 3/4 of pi 10 squared. Okay, this is 100. 100 divided by 4 is 25. 25 multiplied by 3 is 75 pi centimeter square. Now you can take pi as per the instructions and calculate it in decimal form also, right? So let's move to the next question here. In a circle of radius 21 centimeter, an arc subtends an angle of 60 degrees. Where the angle subtended is 60 degrees, so this is angle 60 and radius is 21 centimeter. So this is 21 and this is my center. Let us name these points A, B. Okay. We also need to calculate the area of segment. So let's draw this chord and let's name this point as P. Okay. Now we need to calculate length of the arc. So length, first subpart, length of arc APB, right? What will be its length? It will be equal to theta by 360 into 2 pi r, right? So theta here is 60 degrees, 60 by 360, 2 pi r is 21. So it is 6, 3, 7. So it is equal to 7 pi in centimeter, right? If I take pi equal to 22 by 7 because it seems convenient to me and it is not given in the question what to take. So I am taking 22 by 7. So I have cancelled it. 22 centimeter is the length of the arc APB, right? What is the subpart second? Area of sector formed by the arc. Area of sector. It is equal to theta by 360. So 60 by 360 pi r square. So pi 21 squared, right? So this is 6 pi by 6 into 21 into 21. So if I take pi as 22 by 7, 6 was already there, 21 into 21, 3, 2, 11. So 21 into 11 is how much? 231, right? 21, 21, 231. So 231, the unit will be centimeter squared because we are talking about area of sector. Subpart 3 says area of segment formed by the corresponding chord. So we are talking about this area here. I already have area of sector OAPB. I need to subtract area of triangle OAB from it. Third part, area of segment APB is equal to area of sector OAPB minus area of triangle OAB, right? Now you know that if the angle here is 60 degrees, so this rest of the angles will also be 60, 60. Why? because these angles are anyways equal. This is an isosceles triangle. So if this is 60, the rest of the angle is 120, which can be equally divided here. So this is an equilateral triangle. The area of an equilateral triangle we know already is √3/4 side squared, right? So area of segment APB is area of sector OAPB, which is 231 centimeter square, minus area of triangle OAB, which is √3/4 side squared. What is the side here? It is 21. Okay. All the three sides are equal, right? So this is 231 minus √3/4. This is 441. Okay. I leave the calculation to you. Okay, and just don't forget to write centimeter square in the end, right? So this is how we will calculate area of segment APB. √3 can be taken as 1.732 approximately, and then you can do the further calculations. Okay, let's take one more question here. A chord of a circle of radius 15 centimeters subtends an angle of 60 degrees. So there is a chord, and this is radius 15 centimeter, and this angle is 60 degrees. Okay. So if this angle is 60 degrees, we know that these two angles are also 60 degrees. Why? Because this triangle is an equilateral triangle, or you can think that these two are radii, so this triangle is always isosceles. If this angle is given as 60, and in internal angles of a triangle are 180 degrees in total, so 120 degrees is left, so it will be divided equally in these two angles, 60-60 each. So this is an equilateral triangle, right? Now we need to find areas of minor and major segments. So let's find area of minor segment, which is this one. So it is equal to area of this sector, which is 60 by 360 pi r square, minus area of this triangle, which is √3/4 a square, which is again 15. Okay. So this is 6. So you can simplify it further yourself, or let me simplify it a little bit. 15 square I will take as common, pi by 6 minus √3/4, right? Now you can take this as 3.14, this as 1.732, and do it yourself. Okay. So let's not, I'll leave it to you for your practice, okay, for the calculation's sake. Now area of major segment is equal to area of circle minus area of minor segment, right? Area of circle you know is pi r square, so it will be equal to this, minus area of minor segment you have calculated here, right? So area of major segment can be calculated easily. Okay. So this is how we will calculate areas of minor segment and major segment in this question, right? Okay. A chord of circle of radius 12 centimeter subtends an angle of 120 degrees at the center. So this angle here is 120, and this is the chord that we are talking about, and radius is 12 centimeter. Okay. We need to find the area of corresponding segment. So we are talking about this segment here, right? I have already discussed this triangle with you. This is an isosceles triangle. I will drop a perpendicular here, so it is 90 degrees. These two triangles are congruent by RHS congruency or SAS congruency, anyways you can prove, right? If this is 120, 60 degrees is left, so 30 each. In an isosceles triangle, the base angles are equal, or the angles opposite to equal sides are equal. So we know the angles. This is 90, this is 90, this is 60. right? So we can calculate these sides very easily. So let's do that. This is a 30, 60, 90 triangle. So let's apply sine 30. It is equal to OM by the hypotenuse, which is equal to 12, right? It is 1 by 2, so OM is equal to 6 centimeter. Okay, sine 30 is 1 by 2. So 1 by 2 multiplied with 12 will give me 6. So OM is 6. So to calculate AM, let me do sine 60. It is equal to AM by OA, right? So OA is 12. Sine 60 is root 3 by 2. So AM is equal to 6 root 3, okay, centimeter. So I've got AM, I've got OM. So area of triangle OAM is equal to half AM, which is 6 root 3, OM, which is 6. Okay, so it is equal to 36 root 3 by 2. So area of triangle OAB is equal to twice of 36 root 3 by 2. 2 gets cancelled here. 36 root 3 centimeter square, right? So now I've got the area of this triangle. Area of this circle is pi r square. So if I subtract the area of this triangle from the circle, area of this sector OAB is theta by 360 pi r square. Theta is 120, right? So we can calculate the area of this sector. We have already calculated the area of this triangle OAB. We will subtract the triangle from the sector to get the area of this segment. So area of minor segment is equal to theta by 360 pi r square minus area of this triangle, which is 36 root 3. So you calculate this and then write the unit as centimeter square. So this is the area of this segment, right? A horse is tied to a peg at one corner of a square shaped grass field of side 15 meter. So there is a square shaped grass field. Let us say this is the grass field that the question is talking about, right? And the side is 15 meter. Okay, right? Now there is a horse which is tied at this end, okay, at one corner, and by a rope 5 meter long. So if the rope is 5 meter long, so it will be something like this. Let us say this is the rope and it is 5 meter long. Now we need to find the area of that part of the field in which the horse can graze. By giving the horse can graze, it means the maximum area is to be calculated, right? So horse can graze up to the maximum area possible. So if the rope is 5 meters long, if horse starts moving in this area, this is the area, right? And the horse can move in this area only, right? Because the rope will restrict its movement to this area, right? So this will be a quadrant of a circle. Horse can move in this area only due to the rope, okay, restrictions due to the rope. So we just need to calculate the area of this quadrant, right, where the radius, so subpart 1, radius is 5 meter, okay, and this is angle is 90 degrees, so it is a quadrant of a circle. So the area that can be grazed by the horse is 1/4 of pi r square, right? The area of a quadrant is 1/4 of the area of the circle. So this is the required area, 25 by 4 pi meter square is the unit, okay. If it is given that pi is to be taken 22 by 7, then we can calculate it further by writing like this, okay. And then again I'll leave the calculation to you, right. Let me just simplify this numerator and denominator, then I'll leave it to you. So it is 550 by 28 meter square. So this is the area that horse can graze with a rope of 5 meter, right. So second part wants us to calculate the increase in grazing area. So we will find the new area as per the new dimensions given, and then we will subtract the old area from it to find the increase. So now the rope is 10 meter long, so the horse can graze up to this area. So this time the quadrant of, again this is a quadrant of circle, but the radius of this circle is 10 meters. So the area is 1/4 pi 10 square now, right, and this is in meter square, okay. So increase in grazing area is increase in grazing area is equal to this new area pi 10 square minus the old one pi 5 square, right. The question doesn't want us to calculate the new area, it wants us to calculate the increase in grazing area. So I am subtracting old area that was according to the 5 meter length of the rope. This area is as per the 10 meter length of the rope, and this is the difference. So 1/4 pi 10 square minus 5 square, so which can be written as 1/4 pi, this is 100, this is 25, so it is 75, so I can write it as 75/4 pi meter square. This is the overall increase in the grazing area, right. Okay. Now a brooch is made with a silver wire in the form of a circle, right, whose diameter is 35 mm. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors. So the figure will be something like this. There is a circular brooch, okay, and there are 5 such diameters, 2, 3, 4 and 5, okay. There are 5 diameters, these are equally spaced, okay, because it divides 10 equal sectors. So the figure that I have made may not be the exact figure, but it will give you the idea. These are exactly same areas, okay, as per the question, right. So now the first part says total length of the silver wire required. So look at the figure, where is the silver wire used? In these 5 diameters and this circumference, right. Now we know that diameter is 35 mm, so 5 into 35 plus what is the circumference? It is 2 pi r or pi d, where d is the diameter, right. So 5 into 35 will become 175 plus pi into d, d is 35, right. So this is the length of wire in mm that is required. This is 35 pi. So let me simplify it further by taking it 22/7. So this is 5,110. So if I add 110 in 175, it will give me 582. So 285 mm of length of this silver wire is required to make such a brooch, right, which has 5 diameters and a circumference, okay. And the next part wants us to calculate the area of each sector of the brooch, right. How many sectors are there in total? 10 equal sectors. So if I calculate the area of circle and divide it by 10, This will give me area of one sector, right? So 1 by 10 into 22 by 7 into what is R? The diameter is 35 mm. So what will be the radius? Radius will be half of diameter. So 35 by 2 into 35 by 2 is my answer for area of one sector, right? Now if you simplify it, 5, 11, right? This can be 5 2s are 10, 5 7s are 35. Now this is 35, so 385 divided by 4, and the unit, this is the area that we are talking about, so the unit will be mm squared, right? So this is the area of one sector of this bruch, let us say this sector, okay? And all the sectors are of equal area, right? So it can be the area of any one sector, right? I have just shaded it to make you visualize about the area that we are calculating here, okay? Now we have got an umbrella which has 8 ribs which are equally spaced, okay? So there is an umbrella something like this, okay? So here is an umbrella and there are 8 ribs. So what I mean by 8 ribs, if I assume it to be a flat circle, so what will happen is, it will, if I make it flat umbrella, so it will give me 8 sectors, look at this, 1 2 3 4 5 6 7 8, right? And ribs are these 1 2 3 4 5 6 7 8. So these are the 8 ribs that the question is talking about, and these are 8 sectors that it is divided into. So assuming it, the umbrella to be a flat circle of radius 45 centimeter, so this radius is 45 centimeter. Find the area between 2 consecutive ribs of the umbrella. So this is the area that we have to calculate. This is again just to visualize that we are calculating this much area, although all these areas are same, okay? So we are just calculating the 1/8 of the area of this entire circle, right? Because there are 8 such sectors that I have shown you. So area between any 2 consecutive ribs of the umbrella will be equal to 1/8 of the area of the circle, this circle, okay? And what is the radius of this circle? 45 centimeter. So pi 45 squared divided by 8 will be the area between 2 consecutive ribs. Now this is just the calculation part is left, so you can simplify it like this. It depends on what value of pi you take, 22 by 7 or 3.14. If it is mentioned in the question, you have to take the same value. Otherwise, you can take any value you are convenient with, okay? So this is 4, 11, 28 in the denominator, and 45 into 45 is 2025, and then you multiply 2025 with 11, so you will get your answer for the numerator 22275, right? This is the numerator, 28 is the denominator, and what will be the unit? Centimeter square. Okay, so this is the area between any two consecutive ribs of this given umbrella. Okay, a car has two wipers which do not overlap, right? I hope you have seen the wiper of the car. There are two wipers like this. Let us say this is one wiper, this is second wiper. When it rains or when there is water on the windscreen, the wiper, you can move the wiper like this, right? Let us say wiper comes here and this wiper comes here, cleaning the windscreen of your car, right? And this is the angle that the wiper sweeps through. Okay, so this area is being cleaned by this wiper in one sweep, right? Find the total area cleaned by each sweep of the blades. So at one sweep of the blade, it will clean this area. One blade will clean this much area, second blade will clean the same area, right? Like this. So if I calculate the area cleaned by this one wiper, I can just double it to find the total area. So it will be double of area cleaned by one wiper, which is 115 by 360, theta by 360 pi r square, right? Pi, and what is the radius? 25 centimeter. So this is the area that will be cleaned by both the wipers in one sweep. Okay. So this is equal to 2 into 115 divided by 360. I can take pi as 22 by 7, and this is 25 into 25. This is just the calculation part again. So I expect you to do the calculations yourself. So I am leaving it here. But do not forget, once you calculate this, right, then write the unit as centimeter square. Okay. So in this question we had nothing new. You should just know that the wiper moves like this, right, in the form of it cleans the area in form of a sector of a circle, right, and the angle is already given. So we just need to calculate the area of a sector having an angle 115. So we know that area of a sector is theta by 360 pi r square. So theta is 115 and radius is also given 25 centimeter, because the length of the wiper is 25 centimeter, right? So if the wiper moves, its length will act as the radius of the circle, right, or this sector. So this is your answer. Okay. To warn ships for underwater rocks, a lighthouse spreads a right colored light over a sector of angle 80 degrees. So again there is a lighthouse, let us say this is the lighthouse, and it spreads light, right, and this is this sector which has this angle 80 degrees, right, and this distance or the radius is 16.5 kilometer. Okay, we need to find the area of the sea over which the ships are warned. So this is the area where this light will spread, okay, and where the light is spreading, all the ships that are in this area will be warned about that underwater rocks. Okay, so you need to calculate this area. So you need know the area of a sector is theta by 360 pi r square. So theta here is 80 degree. So 80 by 360 pi, what is r? R is 16.5 and square, right? And the unit of this area will be kilometer square, right? So you can further simplify it. 2 by 9 pi 16.5 into 16.5 kilometer square, and then again you can write it 22 by 7 or 3.14 as per the instructions given in the question, and you simplify it further yourself. Okay. I'll show you one or two steps more. You can cancel it by 3, 3s are 9, 3 5s are 15.1. No, 3 5s are 15 again, 5.5. So this will cancel it again at 5.5, right? So it will give you 2 into pi into 5.5 into 5.5. This calculation is pretty simple now, because 2 into 5.5 is 11 into 5.5 into pi. 5.5 into 11 will give you 60.5. So this is equal to 60.5 pi kilometer square. Let us take pi as 3.14, then you can keep on calculating, right? I expect you to do the calculations yourself. Okay. Okay. In this question, there is a round table cover which has got 6 equal designs. So these designs is the question talking about. If the radius of the cover is 28 centimeter, so let us say this is the center and this radius is 28 centimeter. Okay. So what will be this angle? We know that it is a regular hexagon, right? So this central angle, which is this complete angle, is 360 degrees, and it has to be divided into 6 equal parts. So each angle, like this one, is 60 degrees, right? Now we know this side radius is 28 centimeter and this angle is 60. So we need to find the cost of making the designs at the rate of 0.35 rupees per centimeter square. So what is centimeter square? It is talking about the area of these designs. So we need to calculate total area of these segments, 1, 2, 3, 4, 5, 6 segments, right? So we will find area of one segment and multiply it by 6, area of one segment. Once we find this area, total area of the design, right, we know that the rate of making this design is 0.35 per centimeter square. So this is the total area in centimeter square. We will just multiply this area, 6 into area of one segment, by this rate 0.35, and this will give me the cost of making these designs, total cost, right, in rupees. So the only challenge in this question is to find area of one segment, right, and then the multiplication part is left. So how will you calculate area of one segment here? You know that if this angle is 60 degrees, these angles will also be 60 each. Why? Because these two sides are equal, right? If this is 60, these two angles are anyways equal because these are base angles of an isosceles triangle, and this is 60, so 120 is divided equally in these two angles. So this is an equilateral triangle with side equal to 28 centimeter. So area of this segment, area of one segment, is equal to area of one sector. Let us say take this sector here, area of one sector, which is 60 by 360 pi r square. R is 28 square, right? This is area of one sector. We have to subtract area of this triangle from it, and this is an equilateral triangle. So root 3 by 4 a square, side is 28. Okay, this is 28, this is 28, so this also has to be 28 because all the angles are equal and equal to 60 degrees. So this will be my answer for area of one segment. This is 6. So if I take 28 square common, pi by 6 minus root 3 by 4 will be inside, right? Now you need to fill the values of root 3. Let us say root 3 is equal to 1.73, okay, and let us take pi as 3.14. okay, you need to take the values as per the instructions given in the question. So this will be 28 squared into, if this is 3.14 by 6 minus this is 1.73 by 4. okay, now I am doing the calculation part, but you should do the calculations yourself. So if you calculate area of one segment, let us say this is the area, right? You put it here and multiply it by 6 and 0.35, so you will get your answer in rupees. okay, so for the sake of calculations, I can show you the calculations also. This is 784 into, if I take the LCM as 12, this will be written as 6.28 minus 5.19. So it will give you 784 divided by 12, 6.28 minus 5.19, 1.09 will come here, right? So this is the area of one segment. Now for the cost, the total cost is equal to 6 segments are there. So 6 into 784 by 12 into 1.09 is the total area, right? And we need to multiply it by the rate of making this design, which is rupees 0.35 per centimeter square, right? So this will be your answer. Okay, now you multiply 392 with 1.09 into 0.35, and this is your answer in rupees, or the symbol for rupees is this. Okay. Okay, let's look at this next question. Tick the correct answer in the following. So you just have to tick the answer, right? There is nothing to solve in this question. Area of a sector of an angle P in degrees of circle with radius r. So what is the area of a sector with angle P? P by 360 pi r square, right? Radius is r. So this is the area, right? Let's look for the correct option. Here there is no r square, so this option can be easily eliminated. Here, no. This is clearly eliminated. Okay, this is pi r square, but there is 2 pi r square, and in the denominator, if you see, there is 720. So if I multiply the numerator by 2 and denominator by 2, p by 720, 2 pi r square is exactly the same as this, right? So this is my answer option. Correct option is option D.